So now we know a little bit about slope and how to draw lines. Now we're going to look at parallel and perpendicular lines. Parallel lines, as we know, they never intersect. So given the green line, I can draw infinitely many parallel lines. Now if we think about this in terms of slope, the slope of each of these lines has to be the same. If the slope was different, then you'd have a scenario where they eventually would cross at some point. So when you have parallel lines, the slopes, we'll call this one M1, has to equal the slope of the second line, and the third line and the fourth line, whichever ones we may want to identify. But ultimately the slopes are the same. They have the same rise and they have the same run. Now perpendicular lines are a little bit different. Perpendicular means that they are at a 90-degree angle. And again, we have infinitely many perpendicular lines that we could have when given the first initial line. Now in this case here, perpendicular lines have a special property. The slope, M1, its perpendicular slope to it is a negative reciprocal. So let's call this one A over B, rise over your run. Your M2 slope, your perpendicular slope, is going to be the negative, so the opposite sign, and the reciprocal, meaning that you switch numerator and denominator. So for example, if my first line had a slope of, let's say, 2 over 3, then my perpendicular slope, and again this is a shorthand for perpendicular, just like parallel, right? So those are the two signs. The perpendicular slope of the second line would have to be negative 3 over 2. Another example, if I had my first slope was, let's say, negative 4 over 5, the perpendicular slope, M2, is going to have to be, now if it's already negative, when I flip the signs it makes it positive, and I switch my numerator and denominator. So one is going to be positive, one is going to be negative. So now we're given a problem where we're trying to find the slope between two sets of points. So we're looking at between the points AB and CD, and they give you the coordinate points here. There's AB, there's CD. Now we have to determine whether it's parallel, perpendicular, or neither. If the two slopes are the same, then it's parallel. If the two slopes have negative reciprocals of each other, then they're perpendicular. If they fall into either of the other two cases, then it is neither. So we do need to figure out our slopes. Now, before I use M1 and M2, I'm actually going to do M with a subscript AB, so I know it's for the line segment AB, and MCD, so I know it's the slope between C and D. Just makes it that much easier when you're following your work. When we get into harder questions, it's very important that things are labeled appropriately so you can find things quite quickly and easily, and you remember what you're actually solving for. So in this case here, M of AB, you change in your y, so let's say 3 minus negative 5 all over 2 minus 6. And again, if you need to label these, in this case, this was my x1, y1, x2, y2, or I mean you could do the other way around, but either way it's the same thing. In this case I did y1 minus my y2, here I did x1 minus my x2. Okay. If I do the same thing for my other one, let's just finish that one up. Okay. If I do the same thing for the second set of points, x1, y1, x2, y2, so 3 minus my 4, 7 minus my 9, Negative divided by negative becomes a positive, so we get this. So now I'm comparing these two slopes. Between these two slopes, for line segment AB and CD, I have a negative 2 and I have 1 over 2. So they're definitely not the same, so parallel is out. Now I need to see if these are negative reciprocals of each other. Technically, negative 2 is the same thing as negative 2 over 1. So if I change the sign and I reciprocate them, I will then get 1 over 2 as a positive, which is what I have here. So we actually have perpendicular. Once you've mastered identifying whether they are parallel or perpendicular, now we're going to start looking at some algebraic problems where we actually have to solve for a missing variable. So in this particular case, we have 2 points, one that goes through 3 and y, and one that goes through 1 and negative 2. And we're told that it is parallel to the line. Parallel means it has the same slope. So if we have a slope of negative 2, we don't have to change anything in this case. We're going to use that as our m. They want us to figure out what y is. So if we use our m is equal to y2 minus your y1 all over x2 minus your x1, we can plug in what we know and what we need to then solve for. Our m is going to be negative 2 because it's exactly the same. If the question stated that it was perpendicular, you would then have 1 over 2. The perpendicular has a negative reciprocal. Now we can plug in our y values, so our y2, negative 2, subtract our unknown y, all over 1 subtracting 3. So negative 2 is equal to negative 2 minus y, all over 1 minus 3 is negative 2. We still need to isolate for y. So to both sides of the equation, we need to somehow get rid of the denominator. So multiply both sides by negative 2, and then you will get positive 4 is equal to negative 2 minus y. These ones will cross out. We still need to isolate for y, so there's a couple ways you can do it. You can move y to the other side to make it positive, or you can do that at the end, whichever you're more comfortable with. Either way, whatever you do to one side of the equation, you do to the other side. And again, isolate for y, minus 4 on both sides, and then y is going to equal negative 6. Then, because y is equal to negative 6, our missing coordinate is ultimately asked for find y, but if it asks you for the missing coordinate, 3, negative 6 is the final coordinate.